Hello everyone, welcome to another video. Today we're going to have a look at inverse normal distributions. Um, Whereas before we were trying to find probabilities given a normal distribution and a value. We're doing the opposite of that this time. So in this instance, we're given a probability and we need to find a value where that probability is true. So as it says there, the inverse normal, and this is a CAS skill here, tells you the X value that will give you a certain probability. Okay, and so I've just sort of written it there, as you'll see. It says the probability that X is less than a certain value of X is equal to the area. So if you're the area or the probability, and you see in that diagram, what we're talking about is the area less than a value of X. So you see a value of X there, and it's less than that. So it's not greater than it, it's less than that. And that's how the probability of the calculator is expecting you to enter it. It's expecting you to do it less than value. Always, always, always. So don't forget that. Okay, and so given an area, the calculator will say what's the area. It's saying what's the probability up to that value X. Okay, and like I said there, that it's going to give you that value of X that gives you a certain probability. Hope that makes sense. Now, if a question does ask you for a probability where X is greater than a value of X, then you just need to flip it around. So you need to use the probability X is less than X is one, take away that, so the complement of that. So if the question was asking you to find that blue area there, well, that's just going to be one, take away the yellow area. So hopefully that makes sense, that you just need to be careful. Most of the time, you just need to be finding the X less than, but there'll definitely be times where you need to be finding X greater than something as well. So just be careful, be wary that the calculator gives you less than that value of X. Okay, so let's have a look at a question. Example here, what study score will Dave need if he wants to be in the top 10% in the state? Okay, so any study score, all study scores in Victoria average a mean of 30 and a standard deviation of 7. So just remember that we need to use that information here. Okay, so let's just write down some things here. And I always find it helpful, and I'll just to draw what we're talking about here, okay? So I'm going to put our average of 30 in there. And so what he wants, right, is he wants to be in the top 10%. And so in other words, I'll do it in red. In other words, he wants to be here. He wants to know this X. He wants to know what score do I need so that only 10%, can't fit it in that tiny little bit, but 10% are above me, and that means 90% are below him. Okay, so in other words, he wants to be in the 90th, at least in the 90th percentile, for whatever subject we're talking about here. We didn't specify a subject. Okay, and so what that means is that we want the probability X is less than 90. Sorry, not less than 90. X is less than X, so some value. How are we going to get that equal to the area of 0.9? And why is it 0.9? Because remember, the calculator is going to tell us the bit that's less than that X value. So we're talking about the 90% here, not the 10%. Okay, so just be really clear with that. So we just use the calculator. It's just the inverse normal function here. So we go menu, probability, distributions, and we go inverse normal. Okay, inverse normal, and what it asks us is for the area. So remember, the area is less than, so it's 0.9. That's less than our value. Our mu is 30. Our standard deviation is 7. And this is going to tell us the X value that will give us 90% area below. And so that is 38.97. All right. So therefore, still on yellow. Therefore, X is equal to 38.97. So that will have to be a study score, which is close enough to 39. So that means he needs to get a study score of 39 so that he's in the top 10% of the state. And that's how we use inverse normal function. We just remember that for any value that we're trying to find, it's less than that. So the area is 90% under that curve. Hope that makes sense. That's all there is to the inverse normal function, but I just want to also share with you a different type of question that you could get and that they like throwing at you. Okay. And this sort of question is that when you're trying to find an unknown mean or standard deviation, because all of our normal stuff so far, remember how dependent it is on knowing the mean and knowing the standard deviation. So if you're not given one of those two things, then what do you do? So let's have a think about it. There's the steps there to find the z-score, but I'll explain more in this example, and you'll see how this works. So if x has a mean of, so random variable x has a mean of 3.2 and has a 30th percentile of 2.4, so you're given another piece of information. Given x is normally distributed, find the standard deviation. Okay. So again, I always like drawing a diagram. It just helps my brain sort of understand what's going on. So we've got 3.2 is our mean. The 30th percentile is 2.4. What does that mean? That means that if I've got some line somewhere and I've got 2.4, my value of 2.4 there, that means that this area in here is 0.3. That area under there is 0.3. That's what the 30th percentile means. The 30th percentile tells you what value has 30% below it in the graph. Okay, so I've got that there. And so if you look at this and you think, okay, well, I know a bit of information. I could put the area is 0.3, so I could put that in my inverse normal, and you go to your inverse normal calculator and you go here, and you go, yep, no worries, inverse normal, and you go, the area is 0.3. I know the x value. Oh, hang on, no, because I already know the x value, but I don't know the standard deviation. So can you see how this sort of doesn't work? And so we just need to do a bit of rearranging here. We don't know the standard deviation. If we normalize this, then we can actually force it to be something that we know. Because we know that the standardized z-score has a mean of 0 and a standard deviation of 1, we can actually do that to help. So let's just write a few things down. So firstly, we know that the probability, I don't like red, probability that x is less than x, sorry, x is less than 2.4 is equal to 0.3. That's the first piece of information that we know. The probability that x is less than 2.4 is equal to 0.3. That's that yellow area there. Okay, so we know that so far. So what we can do is we can try to change this into our z statistic. Okay, so just bear with me here. All right, so we know that the probability of x take away mu over sigma is less than. So what I've done to that left-hand side, so what I've done there, all right, is I've taken away mu and I've divided by sigma, okay? And so if I do the same thing to the right-hand side, so if I do the same thing to this 2.4, then what does it look like? It'll be is less than or equal to 2.4 take away mu over sigma is equal to 0.3. Okay, so hopefully that you followed that, and you'll see why I did that in a second. Okay, so that 0.3, that's just the 0.3 there. And what I've done is I've just done to both sides of the inequation. I've taken away mu to both sides of the inequation, and I've divided both sides by sigma. Now you might say to me, it's an inequation, and so you got to be careful when you're dividing by positive and negative numbers, and you're right. The standard deviation, though, is always positive, and so that will not change the sign here. Okay, so what do we have here? So let's just have a look at what this is the probability, and if you remember this stuff here, right? X take away mu over sigma, that is the Z standardized score. So that is Z there, okay? And that's less than 2.4. Do we know the mean? Yeah, we did. Minus 3.2, and we don't know sigma is equal to 0.3. Okay, so I'm pretty happy. I'll just rewrite it. Probability that Z is less than 2.4 take away 3.2 is negative 0.8 over sigma equals 0.3. All right, let's just pause for a second and think about this, okay? So now I know that the probability is Z. Z is a standardized random variable that we know is normal. We know has a mean of 0 and a mean of and a standard deviation of 1. So what we can do now we can apply inverse normal to this. Right, so if we apply inverse normal to this now, that will tell us this x value here that will give us an area of 0.3 for a standardized curve. Okay, so hopefully that makes sense. And so therefore, what we're going to have, we're going to get negative 0.8 over sigma is equal to, and the inverse normal function of the calculator is going to tell us what that's equal to. So let's go to it now. Menu, probability, distributions, inverse normal. My area that I want is 0.3. Okay, I want that area there. My mu is 0 because I've standardized that. This is the Z distribution I've got now, not X anymore. This is now Z. So it's got a mu of 0. It's got a standard deviation of 1. And so therefore, it's going to tell me what that's equal to. And what that's equal to there, that negative 0.8 over sigma is equal to negative 0.524. Let's call it that. I'll call 5244. Let's leave it like that. Okay, so hopefully that makes sense. If you go back to the first, the top of the first thing we talked about today is that here it says the inverse normal finds that x value for a certain area. And so what we've done is we've found a certain x value for that area there. And that certain x value is this, which must be equal to that because that's what we had in there. So hopefully you can sort of follow the logic there of what we're doing there. And then we just solve for sigma, okay? So sigma will be equal to negative 0.8 divided by negative 0.5244, and that will be my answer, okay? So negative 0.8 over negative 0.5244, and we get 1.5. I mean, we didn't say how many decimal places for this, but that's how that's done. So you can use that same logic, and you'll definitely get something like this in the exam for finding missing means or standard deviation by using the inverse normal function. Hopefully that makes sense. There's some other ways to sort of do that, but that's sort of my preferred way to sort of keep all your sort of logic sort of ordered as you go through. Hope that makes sense. I'll see you in the next video.